In this problem, it says for bone density scores that are normally distributed with a mean of 0 and a standard deviation of 1, find the percentage of scores that are, and then in the first part we want to find that are significantly high or at least 2 standard deviations above the mean. So I've drawn, well, I have a picture of the normal distribution here, and I've marked on the horizontal axis the z values. So 0, 1, 2, 3, -1, -2, -3. So we want to know what percentage of scores are significantly high, and that's going to be the scores above 2 standard deviations above the mean, or above a z-score of 2. So to calculate this, we're going to go to the graphing calculator, and we're going to press second and variables, and we're going to choose number 2, normal CDF. We don't normally use number 1, which is normal PDF. So number 2, normal CDF, this is going to give us the percentage of values between a lower boundary and an upper boundary, which is what we want here. So I'm going to put in normal CDF, and you may have the wizard that prompts you with what is the lower boundary. So the lower boundary is 2. And then it'll prompt you for an upper boundary, which we don't have here. So that's where we use 1e99, which means 1 times 10 to the 99 power. A very large value to simulate infinity. Now to type this in, we're going to type in the 1, which is really optional. You can leave the 1 out. And then you want alpha and a comma to get the E. And it's going to be a small capital E. And then 99. Okay. And then we put in the mean and standard deviation. And again, if you have the wizard, those are going to be the default mean and standard deviation, which is a mean of 0 and a standard deviation of 1. And when I do this, I get 0.0228, rounded to 4 places, because we want to round our percentage to 2 places. So then I can say, well, this is equal to 2.28%. So that's our answer for part A. So we've got A done. Now we want the percentage of values that are significantly low, or at least 2 standard deviations below the mean. So this would be similar. We're going to use the same function. We're looking for this percentage of values. And this we would calculate by typing in normal CDF. Now my lower boundary is negative 1e99 because we're on the negative side of 0. And we're going up to -2 for our upper boundary. Mean is 0, standard deviation is 1. Now, because we had already calculated normal CDF to infinity, this is going to be the same value, so I don't really need to calculate that, but I wanted to show you what you would type in if you just had to do that one part. And now we want to find the percentage of scores that are not significant. So again, I'm going to switch to red here. So again, I would use normal CDF, but now I'm finding the percentage that are in the middle. So this would be normal CDF and we're going from a lower bound of -2 to an, to an upper bound of +2, and then mean is 0 and standard deviation is 1. And this gives us 0.9545, which would be 95.45%. Now, you may remember from the empirical rule that between plus and minus 2 standard deviations from the mean, we say that we have approximately 95% of the values. And so that's what we're seeing here. We're just being a little bit more precise. And so that's how you solve that problem.